Okay, so we're going to get started here. And again, as a reminder, if you have any questions along the way, send them in the chat. You can send them via Remind or Edsby or shoot me an email. You can ask questions about what we're doing currently, or if there's something else that you want me to look at, we can do that too. Otherwise, I'll take up some questions. We're looking at factoring and graphing x-intercepts. So if you note, you might notice in the going through the textbook kind of content, we skipped over 6.2 because it really is just a review of factoring and applying what we're going to do here anyways. So rather than double it up, made it look a little simpler using this. So again, if you have questions, feel free to ask along the way. Chat, email, Edsby, or Remind, and I will be paying attention to those. To begin with, we'll look at just some of the basic questions. So the questions were 2 ACE, 3 AD, or ACD, 5 AB, 8, and 11. And if we look at a couple of those, we can kind of get that general concept of what's going on and how this is all kind of manipulated and worked around. So this all relates back to factoring. And so you need to make sure you know your factoring. If you need a factoring review, you can look back at the factoring videos. But if we take a look at some of the questions, so in the section 2 here, we have 2 ACE. So if we take a look at something like 2A, where we have y equals 4x squared plus 20x plus 9, and we're being asked to find the x-intercepts. So when we're thinking about this, it's important to note that when we're finding the x-intercepts in general, and this is kind of just an offshoot here, in general what we're doing is we're trying to find out these points right here where the graph is crossing the x-axis. So what's true in that case is that the y value, so on our y-axis here, the y value of those x-intercepts, that's going to be 0. So the y value is going to be 0. So when we're finding the x-intercepts, before we factor, generally what we'll do, we'll set this equal to 0. And then we can go about solving this. And this is an important idea, not as much here, but later on when you see questions where instead of having y equals this, you might have like 73 equals this, then rearranging so that it is 0 equals will become important to solve these equations. So when we're going about solving this, we're looking at trinomial factoring. So we're looking for common factors first, then if it's a complex or simple trinomial, if it's a difference of squares, we'll factor it appropriately. So in this case here, there isn't a common factor between the terms, so what we need to do, multiply that first and last term again. So 4 times 9 and get 36, so positive 36. So we need two numbers that will multiply to positive 36 and add to 20. And so if we go through the series of numbers, we got 1 and 36. That won't work. 2 and 18. 3 and 12. And we keep working our way down here. 4 and 9. And that we have also, am I missing something? 6 and 6. And so in this case here, and I think I got everything, we should have an unfactorable equation. Let me see here. Yeah. Oh, sorry. I'm not even thinking. Sorry. Passed right by it. Yeah, factorable. 2 and 18. 2 and 18 will get 36 and 20. I was looking at the 9. Sorry. Okay, back on track. So 2 and 18 are the numbers that will multiply to 36, add to 20. So now we will continue by adding, rewriting this portion here by addition with those two terms. So we have 4x squared. Now you put 18 first, you put 2 first, doesn't matter. Order is irrelevant. You will get the same result in the end. I'm just going to do this the way I wrote them originally. Plus 9. There we go. So there is our rewritten 20x as 2x and 18x. And then we're going to do the pairs of factors. So we're going to factor the first pair, factor the second pair using common factoring. And when we do, common factor is 2x in the first pair. You're left with 2x plus 1. And then in the second pair, we use the sign of the first one, a positive. Common factor is 9, and you're left with 2x plus 1. Now in general, if you have the same values in both brackets, then what you have is a good indication that you've done everything right. And now we can simply factor that out. 2x plus 1, 2x plus 9. So now we have our equation factored. How do we actually get the x-intercepts? Well, in any multiplication question, if you multiply something by 0, the answer is 0. So either this term is 0 or this term is 0. So either 2x plus 1 equals 0 or 2x plus 9 equals 0. One of those two things is 0. As long as we get select one of them to be 0, we're good. So either that or that. So we solve each of them independently. 2x equals negative 1, x equals negative 1 over 2, and then 2x equals negative 9, and x equals negative 9 over 2. So those right there work out to be our two values, either 1/2 and negative 1/2 or negative 9 over 2. Those are our zeros, and so that will be the x values where x crosses the the y-axis. So these are each of our x-intercepts. So you have negative 1/2 and 0, and negative 9 over 2 and 0 as your values. So that is that that factored and solved. So when you're asked to solve or find the x-intercepts, what you're doing is setting it equal to 0, factoring by whatever method is available to you, and working your way down with either simple trinomials, complex trinomials, or in this case, or different squares. In this case was complex trinomial. So that's our basic kind of concept there when we're going about factoring these. And in any of these situations, that's what you want. You want to set something equal to 0, and then you're going to factor and find those two x values. So if we move into something like number 3, what it's asking is to, let me just switch it over here, find the x-intercepts and the vertex of each parabola, then sketch its graph. So in this case, we've got to find the vertex afterwards, and we can use the x-intercepts to do that. So let me switch back here, transition and over, and so if we look at something like 3, let's look at 3D. So 3D, we're given y equals negative x squared minus 5x. So this one's a little bit different because it's not a full trinomial, but remember, we could always just put a plus 0 at the end to make it the full trinomial. But we start factoring this and solving this the same way. We set the y equal to 0, and then we have negative x squared minus 5x. Now we find a common factor. First, again, we always look for our common factor. In this case, there actually is a common factor. We have, and I'm going to take out negative x. You could just take out x as well, but I like taking out the negative when it's in the front because then the bracket looks cleaner. So we're left with x minus 5. So we have negative x and x minus 5. So either this is 0 or this is 0. Well, for this to be 0, we just have x equals 0, or x minus 5 equals 0. And then we can go about solving that. One here, x equals 5. So those are the two zeros, 0 and 5. So if we were to have a little graph set up here at the side, just a quick little sketch, we're going to have an intercept here at 0 and somewhere over here at 5. So those are my two intercepts, and this is a graph that's going to be opening downward, so it's going to be opening something like this. Now for the vertex, this point right here, recall that these graphs are symmetrical, so that these points are equally distant from the vertex. Thus, if we find the average of that, so for the vertex, the h value of the vertex is equal to the 0 plus 5 divided by 2. So we just add these up, so now we're finding the vertex. And that is equal to 2.5. So this line is x equals 2.5. And to find the y value, we just sub that 2.5 into the original equation. So the y value, or the k value of the vertex, is negative 2.5 squared. Notice how I wrote that. The negative is in front of the 2.5 squared. Okay, so it's 2.5 squared, and then we make it negative. Minus 5 times 2.5. And so now we can calculate that out to get the y value, or the k value of the vertex. And in this case, it is 2.5 to the power of 2. And so negative 6.25 minus 5 times 2.5. And so we're going to get negative 18.75. So that is the y value. That is this maximum. Or sorry, did I do that right? What did I do wrong here? Negatives opening down. Did I copy that right? Yeah. That should be a positive, should it not? I'm making a small mistake here, and let's see what I do wrong. That's 0 and 5. Times 2.5. And x squared, negative x squared. Negative. Okay. Let me double check something here, because I'm making a mistake. Probably should have practiced these beforehand. Let's see, what am I doing here? 6.3. Negative 5 is 0. Oh, I made a mistake way earlier. So, okay, I figured my mistake out. Back here, when I factored out the negative x, this should have been positive 5, which would have made that positive 5, which would have made that negative. Thus, it just changes up our signs along the way. I apologize for that. Made a huge mistake there. It screwed everything up. So my value is negative 2.5, which thus switches things up quite a bit. Okay, so negative 2.5 to the power of 2 is going to be positive. Sorry, this is going to be negative 6.25 minus, but this is going to be plus now. Plus, and so we're going to get 6.25. Is that right? I believe. No. Yes. Yes, that's right. Okay. So there we go. So it's 6.25. So this is actually switched. So it should be over here. and my graph should be open on the other side. And again, I apologize for that. My mistake. Silly errors can cause big problems. So it's going to go this way, like that. My graph's looking terrible now as I fix it. But this will be at -5 and 6.25. There we go. Graph's opening properly. So again, when I factored out that negative x, I should have factored out the negative here, which switched all the signs, thus moving everything to the opposite side, and thus correcting the y-intercept value. All right. So if you move on to questions like number 5, A and B here, what you're looking at is find the zeros, the vertex of each, and then so you're doing the same thing, just working with some larger numbers, more practice. Again, you're going to look for common factors, then you're going to, and I believe in all these cases they're complex trinomials, and then you will find the zeros, find the middle to get the x value and sub in that x value. The little bit tougher is when we switch over to questions like number 8 and 11, where we have some word problem type things. So in the case of 8 and 11, I'll take up both of those. So question number 8 has us looking at a parabolic cross section of a metal garage, and being modeled by the formula height equals the negative of the distance squared plus 4, where h is the height in meters above the ground and d is the horizontal distance in meters from the center of the garage. How wide and how tall is the garage? Sketch it, and then what are the d's? Are they valid in this relation? And that's an important concept here too. So let's take a look at the first part, 8a. So in 8a, we had that parabolic model of h equals negative d squared plus 4. So we want to know how wide and tall the garage is, knowing that the d's are going to be the distance from the center of the garage. So let's first factor this out so that we kind of see what we're working with. So we set this equal to 0. We're going to find out where that garage kind of lands on either side. So now I'm going to factor out a common factor if there is one, which there isn't. And I'm going to continue looking. Is there anything here that we can factor? No. So there's no factoring here. So in this case, what we're going to do is we're going to rearrange this to solve it. So I'm going to take this plus 4, move it to the other side. So I get negative 4 equals negative d squared. I'm going to get rid of the negative 1. I'm going to divide both sides by negative 1. And I'm going to get 4 equals d squared. And then I'm going to take the square root of both sides. So the square root of 4 equals the square root of d squared. Remember that we mentioned that when we take a square root, there's actually two answers. It's either plus 4 or it's minus 4. So there's two possibilities here. So if we go to sketch this out, which we're asked to do in part B, we found out part of this, but we can use this sketch to help us determine how wide this garage is. So the d's are how far from the middle of the garage it is. So in our case here, this is the middle of the garage, the y-axis, and so the d's are at negative 4 and at positive 4. So our garage is actually 8, and this is in meters, so our garage is 8 meters wide. And in the case of finding the height, again, we just sub in our value. Now we know the center of the garage is going to be at 0, so we could just add and divide by 2, but we're going to get 0 here, so we just sub in 0 for our d value, and we will get 0 equals negative 0 squared plus 4 or sorry, h equals that. So the height is just 4. So our height here is up at 4 meters. So we have something looking like this as our parabola. Now, because this is a realistic situation, a real world type of situation, we wouldn't actually continue the graph underneath. So the whole parabola would look like that, but our actual garage door is going to stop at the ground. It's not going to go under the ground. It's going to stop when it hits the ground. So this is the actual setup for a garage door. Now, is our garage door actually a parabolic shape? Yes, in this case, I believe it is. So we got a parabolic cross section of the garage door here. So it's only a portion of the garage door that we're looking at. So it's a cross section. So this is the shape, but it's going to hit the ground at zeros. So this is our whole graph here. It's going to stop at this line, and it's going to stop here and here. So that's our whole graph sitting within that section. And so that's our height of 4, our width of 8, and then there's our sketch. And then it says for what values of d is the relation valid, and that's what we were mentioning there. The distance is never going to be 5. The garage door is going to hit the ground here. So while we could continue the parabola down here and go to -5 and something, that's not a valid value for our situation here because it doesn't do. It's not fitting within the realistic situation we have. If this was just a general equation and had no actual situation we're trying to connect it to, then yes, the distance, the d value could be anything, but in our case here, our distance is only going to be limited by the real world scenario. So the last one we wanted to look at was number 11. So if we take a look at question number 11 here, we have a parabola with a vertex of -3 and 7, and one x-intercept is -11, and we don't know the other x-intercept. And so we want to find the other x-intercept, and we want to find the y value, the y-intercept. So using that information, so that's what we got here. We only know one x-intercept. We know the vertex. And so we want to kind of create an equation for that. So things we can do. Well, we know that the x-intercepts are the same distance from the middle. So if I just draw a quick little sketch here, I got a point here at -11 and a vertex at -3 and 7. So maybe right here. Okay, so this is at -3 and this would be 7. So we're going to have a graph that's going to look maybe something like this. Okay, so where's the other x-intercept? Well, knowing that, again, this is a symmetrical graph, so it's equally distant from this side to this side, we can find the distance here. So -11 to -3, -11 minus -3, or -11 plus 3, which is going to give us negative, where am I at here? 7, 6, 8, 9. There we go. 8, -8. Got her. Okay, -8. So we're at -8. So this distance here, we're going 8 over that way. So the opposite distance must be +8. So what is -3 plus 8? Well, -3 plus 8 is going to give us a distance of 5. So this point here must be at 5. So this here is what we use to find the x-intercept. So that found our second x-intercept. So now we have our two x-intercepts, -11 and 5. So now we can go back to a general equation. So remember, our vertex form of the equation is y equals a x minus r, x minus r, x minus t in general. We know our two r and t values, and we know an x and a y value. So we can fill all this in to find an a value and then work this out to solve for the missing value. And so what we have here is y equals a x plus 11, right? Because everything switches when it goes inside the brackets. It's negative r, so negative 11 becomes positive 11. Positive 5 becomes negative 5. And then we'll sub in our x and our y value. 7a, and this is negative 3 plus 11, negative 3 minus 5. And we're left with negative 3 plus 11 is going to give us 8, and then negative 8. We multiply those together, and we're going to get negative 64a, and then divide on the other side. So there's our a value, and we can sub that in and create ourselves the equation. X plus 11, x minus 5. And now if we want to know the y value, we know the x value of the intercept, we want to find the y-intercept. So to find the y-intercept, then we set the x value is equal to 0. So we just simplify that down, and then we do our final multiplication here, and I got negative 55 times 7 divided by 64, and so our y value is going to be about negative 6.02-ish. So that's an approximate value, and so that would be our y value and how we find that. Alright, so that's about it for today. I apologize for bumbling around a little bit. I was trying to go quickly and make it a little bit of a shorter video. Again, if you have questions along the way, please send me emails, send me EDSB messages or remind messages, whatever works for you for any additional help. And then we will see you guys next week.